Okay, I will make a quick video of Chapter 7 test review. The previous video, I asked you to input these data. After you input those data, maybe I should share the whole screen. Okay. All right, so, okay, and the first question, maybe I do 1, 2, 3, and it's 4, 5, maybe 30 minutes later. Number 1, make an appropriate graph to display the same sample data. Describe what you see. So this is what I input, and it's kind of interesting. It's you could say roughly symmetrical, but it's a little bit as disoriented. Could be, you could say it's a unimodal, bimodal, but nearly symmetrical, you could say. But where is it? SOCK, right? So SOCK. That's a shape. O is no outliers. C for center. Let's see. Center is here. X bar, right? 16.72. Okay. And that's the mean. And spread is the ranges from here to here, right? I don't have lower end. Low end is this one, right? 15.46 to I think somewhere around. I don't have max here. Forgot to. Yeah, I have it here. Okay. Go here. The max is, guess, 17.89. So that's the range. Okay, so spread can, maybe you can use the standard deviation, which is standard deviation sample, so 0.664. Okay, so that is the description. Okay, number 2, assume the battery production process is working properly, which is, if they're talking about properly, they're talking about this. Mu is 17 and standard deviation is 0.8, okay? However, they're going to take, describe the shape, center, and spread and sampling distribution of X bar, which is random samples of 50 batteries. So sampling distribution of random samples 50. Justify your answer. Okay, so before I justify my answer, we have to check the condition. Is 50 batteries is less than 10% of the whole entire batteries? Of course, right? It's only 50, right? So so this is okay. How about the count? So 50 counts, right? 50 counts is at least 30. N is at least 30, so 50 is okay. So now you run this equation, okay? Mu of X bar equals sigma divided by square root of n. So sigma was given at the beginning, which is 0.8, I guess, yeah, 0.8 here, divided by square root of 50, okay? Then my calculation is 0.113, let me see. So let me run the calculator. So after that's the standard deviation we have to use. The mu is still 70 and 17. Okay, so let's see. Let's do the equation. Let's make sure equation is right. Okay, so 0.8 divided by square root of 50. 0.113. So okay, then 0.1131. So let's use this one. Now mu is 17. 17 means 17 hours. The battery lasts 17 hours. One standard deviation above is 17,113. One standard deviation is 16.89, actually 887, right? So this just mine's nearest hundreds, this is nearest thousand. So so if you run normal CDF, what I was asking, they asked number 3 question. Okay, we use this data now, 16.718. Let me cut and paste. Okay, so I will cut and paste here. And let's use 0.113 as a data, okay, not 11. Find the probability of obtaining random sample of 50 batteries with mean lifetime is 16.718 hours or less if the production process is working properly. Show your work. Based on your answer, do you believe that process is working properly? Why or why not? Okay, so let's run the normal CDF. Okay, so go here. Normal CDF. So I will just check the highlighted section. So negative 1 times 99. So negative infinity 2, upper is 16.718. Mu is 17 hours. Standard deviation is 0.113. Okay, let's run this. Okay, 0.00625, which is very small. So let me see. So nearest 1,000 is going 0.006, I guess. So let's see. So there is less than 1% chance that a random sample of 50 batteries would have a mean lifetime of at most 16.718 hours. If the process is working correctly, right? So this is so small, so it isn't plausible that the process is working correctly. Okay, so you can conclude that. Yeah. All right. So I would come back with 4 and 5. The question 4 and question 5. So you can pause here. I will hide the answer here. You can do your own 30 minutes later. Okay. I will see you in 30 minutes.